Welcome back, everybody. This is the last section, the last of the new stuff in Chapter 3. It's kind of a throwaway lesson. It doesn't really fit in with much of anything else that we've been doing, but we got to cover it, and this is where it is. We are going to be looking at exponents, precisely what negative exponents and exponents of 0 mean. First, let's review some of the old rules. Without solving, meaning I don't want you putting into your calculator 5 to the power of 3, can you simplify? And what is the rule that I used? Add exponents. When we're dividing, I didn't actually have to write the 1 there, but just so you could clearly see. And the rule is subtract. And finally, we have the power of a power. And this is when you multiply. Now, if you don't remember these rules, that's fine. I know that when I taught my grade 9s that they were rather confused by this, but hopefully you know this. It only ties in a little bit. We actually use the multiplication. We use them all the time. We just don't think of them as being specific rules anymore. All right. So let's go through. In the classroom, I'd give you a few minutes to do this. If you wish to do this, then you are certainly welcome to. Put it on pause, and away you go. Now, if you put this into your calculator, you probably got 0.5 and 0.25, otherwise known as 1/2 and 1/4. Now, the reason I've written it out as fractions is that it's probably easier to see what's going on. Once again, if you put into your calculator 10 to the power of -1, you'd have gotten decimal 1. But what you wouldn't see is that the fraction version kind of spells out what's happening. So as we're going down the list, it's almost like we're dividing by 10 every time. Likewise, on the left, as we go down the list, it's like we're dividing by 2 every time. Now, I guess we didn't really talk about it. Where it's 2 to the power of 0 and 10 to the power of 0, both of them equal 1. And the reason for that is that anything to the power of 0 equals 1. Doesn't matter what it is, at least until we get to the variables. Variables, the only rule is that you can't have 0 to the power of 0. Otherwise, any number to the power of 0 gives you 1. Now, numbers with negative exponents result in the reciprocal of the base to the same power. So that's a whole lot of fancy schmancy talk. We talked about negative reciprocals when we were talking about slopes and trying to find when they were 90 degrees. And this is the same thing. We're taking the value and we're flipping it. So although we don't usually think of it, 5 is really the same thing as 5 over 1. Sorry about that bracket there. So when we take that negative sign and flip it, it becomes 1 over 5. Now notice, when you're going from the first one to the second one, it's -2, and now it's a +2. So the value of the number doesn't change, but as soon as you flip that fraction, the negative on the exponent disappears. Now, because everything's in brackets, we square the 1, we square the 5, 1 squared is 1, 5 squared is 25, and that's where that second fraction comes from. Likewise, 4 over 7, this one's actually easier to see. The negative sign flips it, so it becomes 7 over 4. And again, The exponent on the 2, it goes from being a -2 to a +2 once we flip it. Because everything is in brackets, it means everything's getting squared. So it's 7 squared, 49, 4 squared, 16. Okay, so the fancy schmancy mathematical way of showing this is that whenever you have a to the power of -n, we get 1 over whatever a was to the power of +n. So let's try a couple and make sure that you really know what you're doing here. 5 to the power of 3, this is just like we used to do, well, last year. Hopefully you're going to either have to use y to the x or the caret button on your calculator. It will depend on your calculator as to how you do it. And the order that you do it in, just make sure that your answer matches my answer once you're done. So the first two are the same way. If you put into your calculator 17 to the power of 0, it will spit back at you 1. Doesn't matter, it should work. Hopefully you've got that memorized, but if not, that's fine. 3 to the power of -3 reduces to, becomes 1/3 to the power of 3, and there should be another line, and there it is. 1 to the power of 3 is 1, 3 to the power of 3 is 27. So if you don't know that off the top of your head, 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. You can put the 3 into your calculator, 3 to the power of 3, and it'll spit 27 out at you. Now, when we assign homework, when I give you the assignment, I will be explicit. This must be as a fraction. And as always, if I tell you I want a fraction in the answer, you had better give me a fraction. I will not accept the decimal. 4/5 to the power of -1. Then you take the value and flip it, so it becomes 5 over 4. All right, a couple more for you guys to try. A little bit more complex, but we're reviewing some of those rules here. So when we add the exponents, it ends up being 4 to the power of 0, which means the answer is 1. -2 divided by, so 2 subtract -5, right? Division can subtract, and it's already -5. So when we subtract the negative, it's a +7, and we put that into the calculator. Notice that the negative sign is inside the brackets, so it also is being taken to the power of -7. Remember your BEDMAS rules. You have to do what's inside the brackets first. So 4 to the power of 2 divided by 4 to the power of 5, 4 to the power of 3. Power rule says we multiply them together, which makes it 4 to the power of 6, and then we expand it out. That last one is not correct. Oh, here. Should be much better written, 3 to the power of 4. 3 to the power of 4. It's going to become a big thing later on. This is just kind of introductory. When we're given a value and we're trying to figure out how to solve for the exponent. And what the goal is make is we got to try and make both numbers have the same base, most of the time anyways. So here we have 2 to the power of n. So since there's only one value here, it has to be 2, which means we got to take 2 to the power of something to get us -16. So we know that the exponent's going to be negative, right? Because to go from 2 to 1 over 16, we have to have a negative sign in there to turn it into a fraction. Now the question becomes, how many times do we multiply 2 by itself to get 16? 2, 4, 8, 16. So that means there's a 4 in there. N equals -4. Okay, memorization thing, 7 to the power of n equals 1. Well, n has to equal 0 because this is a definition thing. Anything to the power of 0 is 1. This one's a little bit different. There is a button. Well, okay, let's partly deal with things. Now, we know with that negative sign that we can turn it into a positive, into a regular old 8. From there, you're figuring out what number times itself 3 times is going to give you an 8. On the button, somewhere on your calculator, you should see a button like this. Or it'll be something similar. And it's probably right above your y to the x button. Because if you type that in, it'll spit the answer out at you. Oops. N equals 2. Now, hopefully that one's simple enough that you can do it. 2 times 2 times 2 is 2 times 2 is 8. No, 2 times 2 is 4. 4 times 2 is 8. Yeah, so much for it being pretty simple, eh? Anyways, but if not, that button is your get out of jail free card. So if you can figure out how to do it, great. We're not going to make these questions too hard. Again, this is meant to be introductory, and you don't see it again until grade 11. Grade 11, you're going to be doing this all the time. Right now, it's just introductory. So there you go. There's the very last lesson for chapter 3. The homework questions will be posted in the review section. My apologies. The review questions will be posted in the review section. However, you can also find it at the top of the PDF that has all the homework solutions on there. And yeah, your assignment is located under the assignment tab. You can complete it. It will be due. You will have to hand it in through the D2L. The link can be found under the game plan tab. Tests and quizzes will be coming at some point, and I will post a timeline for what I'm hoping you should be able to do. But generally speaking, 3.1 is 1 day, 3.2 is 2 days, so on and so forth. So that would make this 3.6, so 6 days, 3.7 for review, 3.8. So it would be the Wednesday of the second week back is when you should be aiming to be ready for the test. Thanks, everybody. Have a good one.